Hello, in this lecture we will find out the value of angle x and we will solve the question using two different methods. In the drawing we have triangle PQR. We know that QS equals to SR. We also know that angle PSR, this angle PSQ, this angle equals to 45 degrees. Angle PQS, this angle equals to 3x, and angle PRS, this angle equals to x, and we want to find out the value of angle x. So we will start with the first method, and we will define angle PSQ, this angle as alpha, and we will also define angle SPR as beta, and we will find out the value of angle PSR, so we will define it as y, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees, so the sum of the angles on the upper side of the straight line QR is equal to 180 degrees. That is to say 45 degrees plus the size of angle y must be equal to 180 degrees according to the rule that I mentioned. And so 145 degrees plus the size of angle y must be equal to 180 degrees. Here we will subtract 45 degrees from this equation and we will get that angle y equals to 180 degrees minus 45 degrees. That is to say it equals to 135 degrees. Okay, so we found out that angle y equals to 135 degrees, so we will substitute angle y by 135 degrees. In the next step, I will present to you a new rule. Actually, it is the law of sines. The law of sines is true in any triangle. So in any triangle, if we have a triangle that can be any triangle, and we know that the length of this side of the triangle is equal to A units, the length of this side of the triangle is equal to B units, and the length of this side of the triangle is equal to C units. And we also know that this angle is equal to A degrees in its size, this angle is equal to B degrees in its size, and this angle is equal to C degrees in its size. Then, according to the law of sines, A over sine A is equal to B over sine B, and it is equal to C over sine C. Okay, I'll repeat again. A over sine A equals to B over sine B equals to C over sine C. From this formula we can derive that A over sine A equals to B over sine B here we will multiply this equation by sine A, and then we will divide it by B, and we will get that A over B is equal to sine A over sine B. So we got that A over B equals to sine A over sine B. So what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. I repeat again, the ratio between the side lengths in any triangle is equal to the ratio between the opposite angles. So you can see here, angle A is located in the opposite sides of this side, and angle B is located in the opposite sides of this side. So we will return to our original drawing, and in our original drawing we can create the equation that states that PS over QS is equal to PS over SR. I will repeat again. Equation number 1 states that PS over QS equals to PS over QR. PS over SR. PS over QS equals to PS over SR. I repeat again. PS over QS equals to PS over SR. Why this equation is true? This equation is true because according to what is given us in the question, QS equals to SR. You can see here QS equals to SR. But according to the rule that I mentioned, that the ratio between the side lengths in any triangle is equal to the ratio between the opposite angles, we will get that if we relate to triangle PQS, then PS over QS will be equal to sine 3x over sine alpha. I repeat again, PS over QS will be equal to sine 3x over sine alpha. And if we focus on triangle PSR, then we'll get that PS over SR is equal to sine X over sine beta. I repeat again, PS over SR in triangle PSR will be equal to sinus X over sinus beta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQS, we know that the sum of the angles in triangle PQS is equal to 180 degrees. That is to say, angle alpha plus 3x plus 45 degrees must be equal to 180 degrees. I'll repeat again on the question number 2. Moving to question number 2, the sum of the angles in triangle PQS is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract from this equation number 2, 45 degrees and also 3x, and we will get that angle alpha will be equal to 180 degrees minus 3x plus 45 degrees. Okay, so we actually found out the value of angle alpha in terms of x. Likewise, we know that in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, angle beta plus angle x plus 135 degrees must be equal to 180 degrees. Again, in triangle PSR, we know that the sum of the angles is equal to 180 degrees. That is to say, beta plus x plus 135 degrees equals to 180 degrees. Here we will subtract 135 degrees and also x from equation number 3. This equation, and we will get that angle beta equals to 180 degrees minus 135 degrees is 45 degrees minus x. So we found out that beta equals to 45 degrees minus x according to equation number 3, and according to equation number 2, angle alpha equals to 180 degrees minus 3x plus 45 degrees. So now we can substitute alpha and beta in this equation number 1, by the values that we found for alpha and beta in equation number 2 and equation number 3. So we will do it now, and we will get that according to equation number 1, sinus 3x over sinus alpha, and alpha according to equation number 2 equals to 180 degrees minus 3x plus 45 degrees, and it equals to sinus x over sinus beta, and beta according to equation number 3 equals to 45 degrees minus x. Now we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we will get that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. So we will write down again equation number 3 after we change the value, after we use the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, and we will get that according to equation number 1, we will get that sinus 3x over sinus 3x plus 45 degrees, that is sinus alpha, equals to sinus x over sinus 45 degrees minus x. So here we will cross multiply this equation number 1, and we will get that according to equation number 1, sinus 3x times sinus 3x times sinus 45 degrees minus x equals to sinus x times sine 3x plus 45 degrees. So here we will multiply this equation number 1 by 2, and we will get that 2 sine 3x times sine 45 degrees minus x equals to 2 times sine x times sine 3x plus 45 degrees, and now we will use the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. So we'll use this trigonometric identity in order to simplify our equation number 1. So here in our specific to the equation number 1, in the left side of equation number 1 we have 2 sine 3x sine 45 degrees minus x. So here A will be equal to 3x and B will be equal to 45 degrees minus x, and therefore we get that 2 sine A sine B equals to cosine A minus B. That is to say, cosine A minus B is cosine A is 3x and B is 45 degrees minus x. So 3x minus x is 4x, and 0 minus 25 degrees is minus 25 degrees. And we also have to multiply it by, we also have to subtract minus cosinus A plus B. So it is minus cosinus A plus B. A is 3x and B is 45 degrees minus x. So 3x plus minus x is 3x minus x, that is to say it equals to 2x. And 0 plus 25 degrees, it equals to 0 plus 45 degrees is equal to 45 degrees. Okay? So we finished with this side of equation number 1. Now we will treat the other side of equation number 1. Here we have 2 sine x sine 3x plus 45 degrees. So here A equals to x, A equals to x, and B equals to 3x plus 45 degrees. So 2 sine A sine B equals to cosine A minus B. Cosine A minus B, A is x and B is 3x plus 45 degrees. So x minus 3x is minus 2x. And 0 minus 45 degrees is minus 45 degrees. So we actually got the expression cosinus minus 2x plus 45 degrees. But because of the trigonometric identity that states that cosine minus x equals to cosine x, Actually, we can change the negative signs, the negative sign of cosine minus 2x plus 45 degrees to positive sign according to the trigonometric identity that cosine minus x equals to cosine x. So we'll change it to positive sign. So here we got in conclusion that it is actually cosinus 2x plus 45 degrees, and we also must subtract minus cosinus a plus b. So minus cosinus a plus b, a is x, b is 3x, x plus 3x is 4x, and we also have 0 plus 45 degrees is 45 degrees. So here we will add to this equation number 1, cosine 4x plus 45 degrees, and we'll get that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is equal to, we will add to this equation number 1, cosine 2x plus 45 degrees, and cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees will be equal to 2 cosine 2x plus 45 degrees. So here we have cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees. We can use the trigonometric identity of cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And we will also use the trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A times sine B. We'll use this trigonometric identity in order to simplify the expression 2 cosine 2x plus 45 degrees in the other side of equation number 1. So first of all, we treat this expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees. Here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees and according to this trigonometric identity, that cosine C plus cosine D equals to 2 cosine C plus D times cosine C, 2 cosine C plus D over 2 times cosine C minus D over 2, we will get that our expression will be equal to 2 cosine C plus D over 2 is 4x plus 4x is 8x, and 8x over 2 is 4x. So it is 2 cosine 4x, and minus 45 degrees plus 45 degrees is 0. And we also must to multiply it by cosine C minus D over 2. So it is cosine C is 4x minus 45 degrees and D is 4x plus 45 degrees. So 4x minus 4x is 0, and we have minus 45 degrees. Minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But because of the fact that cosine minus x equals to cosine x, you can write down that cosine minus 45 degrees equals to cosine 45 degrees. Okay? And then we treat this expression of 2 cosine 2x plus 45 degrees according to the trigonometric identity of cosine A plus B equals to cosine A times cosine B minus sine A times sine B. We get that here A equals to 2x and B equals to 45 degrees. So cosine A plus B equals to cosine A cosine B, that is to say it equals to cosine A is 2x and B is cosine 45 degrees. Minus sine A is sine 2x times sine 45 degrees. So here we will divide this equation number 1 by 2 cosine 45 degrees. Here, so 2 cosine 45 degrees will get cancelled, and here also 2 cosine 45 degrees will get cancelled, and here we have 2 and sine 45 degrees equals to cosine 45 degrees. So here 2 sine 45 degrees will get cancelled, and what is left after we cancel 2 cosine 45 degrees from equation number 1? What is left from equation number 1 is that cosine 4x equals to cosine 2x minus cosine 4x. This is actually cosine 2x minus sine 2x, because we have sine A times sine B, it is sine 2x times sine 45 degrees, and sine 45 degrees will get cancelled. So we left only with minus sine 2x. So we got in conclusion that cosine 4x equals to cosine 2x minus sine 2x. So here we will add to this equation number 1 sine 2x, and we will get that sine 2x, and we will subtract cosine 4x. Sine 2x equals to cosine 2x minus cosine 4x. And we know that sine 2x equals to 2 sine x cosine x, so I'll write it down. So we have cosine 2x minus cosine 4x. We will use the trigonometric identity that states that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. So here we know that C equals to 2x and D equals to 4x. So cosine C minus cosine D equals to 2 sine D plus C over 2. It equals to 2 sine D is 4x and C is 2x, so D plus C is 2x plus 4x is 6x, and 6x over 2 is 3x, times sine D minus C over 2. D is 4x and C is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So it is sine x. So here we will divide equation number 1 by 2 sine x. So here 2 sine x will get cancelled, and here also 2 sine x will get cancelled. And we got that cosine x equals to sine 3x. And according to the trigonometric identity, that cosine alpha equals to sine 90 degrees minus alpha, we will get that cosine x equals to sine 90 degrees minus x, and it equals to sine 3x. We got that sine 90 degrees minus x equals to sine 3x. That is to say, 90 degrees minus x equals to 3x. Here we will add to this equation number 1x, and we will get that 90 degrees is equal to 4x. Here we will divide equation number 1 by 4, and we will get that x equals to 90 degrees over 4. That is to say, it equals to 90 degrees over 4 is 22.5 degrees. So we found out that angle x equals to 22.5 degrees. X equals to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. In the second method, we will define angle QPS as alpha, and we will define angle SPR as beta, as we did in the first method. We have already found out that angle PSR equals to 135 degrees in method 1. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if you focus on triangle PQS, we know that the sum of the angles in triangle QPS is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I'll repeat again. In triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees from this equation, equation number 1, and we will get that alpha plus 3x, according to equation number 1, alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that according to equation number 1, alpha plus 3x equals to 135 degrees. Likewise, we know that the sum of the angles in triangle PSR must be equal to 180 degrees, and the sum of the angles in triangle PSR, this triangle, will be equal to beta plus x plus 145 degrees. The sum of those two angles must be equal to 180 degrees. So here we will subtract from this equation, equation number 2, 135 degrees, and we will get that beta plus x equals to 180 degrees minus 135 degrees equals to 45 degrees. Here we will subtract x from this equation, equation number 2, and we will get that beta equals to 45 degrees minus x. So actually, here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 135 degrees. So, because of the fact that both equations, one side of them is equal to 135 degrees, we can create equation number 3 that states that equation number 1 equals to equation number 3. Equation number 1 equals to equation number 2. That is to say, this side of equation number 1 that equals to alpha plus 3x must be equal to this side of equation number 2 that also that is equal to 3 beta plus 3x, because the other side is equal to 135 degrees in both triangles. Okay? Here we subtract 3x from equation number 3, and we will get that according to equation number 3, alpha equals to 3 beta. So we found out that according to equation number 3, alpha equals to 3 beta. So here we will do a construction from point X. We will draw from point Q. We will draw a straight line to PR in such a way that the angle that will be created here will be X. Okay. So the angle that was created by the straight line here, it is X. We will define the touching point between the straight line and PR as point M. So actually, triangle MQR is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to X. We will join points M and S together by a straight line. And MS is the median to the isosceles triangle MQR, and the median to the base QR in any isosceles triangle is perpendicular to the base. That is to say, this angle must be equal to 90 degrees, and this angle also must be equal to 90 degrees, according to rule number 3, that the median to the base in an isosceles triangle is perpendicular to the base. So those two angles are right angles, they are both equal to 90 degrees. So here, in the next step, I will present to you a new rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles to the sum of the two angles that are not adjacent to it. I repeat again on rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have a triangle ABC, so this is triangle ABC. And the interior angles of triangle ABC are alpha, beta, and gamma. Those three angles are defined as the interior angles of the triangle because they are located inside the triangle, while this angle SAB, that is located outside the triangle, will be defined as an exterior angle. So angle SAB is an exterior angle, and according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAB, and the two angles that are not adjacent to angle SAB are alpha and beta. And according to rule number 4, the value of angle SAB, the exterior angle SAB, is equal to the sum of the two angles that are not adjacent to it, that is to say it equals to alpha plus beta. So we found out that this angle equals to alpha plus beta. So we can implement rule number 4 in our drawing. In our drawing we have the isosceles triangle QMR, and if angle PMQ, this angle is defined as an exterior angle of triangle QMR. And according to rule number 4, the value of the exterior angle PMQ, will be equal to the sum of the two angles that are not adjacent to it. And the only two angles that are not adjacent to angle PMQ are those two angles, and the sum of those two angles is x plus x. So we found out that the value of the exterior angle PMQ equals to 2x. And exactly as the value of this angle, the value of angle PQM equals to 3x minus x. I repeat again, the value of angle PQM equals to 3x minus x, that is to say it equals to 2x. So we found out that those two angles of triangle PMQ are both equal to 2x, that is to say they are equal to each other. And we have the rule that in front of equal angles in the triangle there are equal sides. Those two angles are located in front sides PQ and PM, and according to the rule that I mentioned, the sides are also equal to each other, that is to say PQ equals to PM. PQ equals to PM. Okay, in the next step, we will draw a perpendicular from point P to QM, and then we will extend the perpendicular until it touches QS. Okay, so this is the perpendicular. It it is perpendicular to QM, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from point P to QM as L, and we will define the touching point between the perpendicular from point P to QS as point N. So the touching point of the perpendicular from point P to QS is at point N. Okay? Then we will focus on those two triangles, triangle PQL and PLM. Triangle PQL and triangle PLM. On those two right triangles, we know that those two angles are equal to each other, they are both equal to 2x, so angle PQM equals to angle PMQ, and both those two angles are equal to 2x. Okay, so angle PQM equals to angle PMQ equals to 2x. Those two angles are also equal to each other, they are both equal to 90 degrees, so angle PLQ equals to angle PLM, this angle, and they are both equal to 90 degrees. I'll repeat again, angle PLQ equals to angle PLM equals to 90 degrees. And those two angles are also equal to each other according to third angle theorem. So this angle, that is actually angle QPL, is equal to this angle, that is actually angle MPL. So this is angle MPL. Okay, so those two angles, they are equal to each other according to third angle theorem. I'll repeat again. Angle QPL equals to angle MPL, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. The value of the third angle is equal to 180 degrees minus the sum of the two other angles, but the sum of the two other angles are equal in both triangles. Therefore, the third pair of angles must be equal to each other. That is to say, those two angles must be equal to each other according to third angle theorem. So, if we define this angle as angle theta, then this angle must be also equal to theta. Okay? From the drawing you can see easily that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta and it equals to alpha plus beta. According to equation number 3, we already found out that alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta. So we'll do it and we'll get that 2 theta equals to alpha is 3 beta plus beta. So 2 theta equals to 3 beta plus beta is 4 beta. 4 beta, yes. Here we'll divide this equation by 2 and we'll get the theta equals to 2 beta. So we found out that theta equals to 2 beta. So this angle theta equals to 2 beta. And this angle theta equals to 2 beta. But here you can see easily that angle theta minus this angle, that is angle beta, angle theta minus angle beta, must be equal to this angle that is actually angle NPS. So theta, that is 2 beta, minus angle beta equals to angle NPS, that is to say angle NPS equals to 2 beta minus beta, that is to say it equals to beta. So we found out that this angle NPS equals to beta. Likewise, we have here angle MSN that equals to 90 degrees. If we subtract from the right angle PSN that equals to 45 degrees, we will get the value of this angle that is actually angle MSP, that is to say 90 degrees minus 45 degrees, that is 45 degrees, is the value of angle MSP, the value of this angle MSP. So in the next step, we will prove that those two triangles can go into each other. So I will draw those two triangles and we will prove that they can go into each other. Okay, we actually prove the triangle PNS. Triangle PNS can go into triangle PMS. I repeat again, we prove that triangle PNS, the green triangle, triangle PNS, it can go to the right white triangle, triangle PMS. I write it down. The green triangle, triangle PNS, can go to the white triangle, triangle PMS. So why they can go into each other? First of all, we have we have already found out that Pn equals to Pm. Here we have actually two angles that are equal to each other, angle NPS, this angle in the green triangle is equal to this angle MPS, and both angles are equal to each other, they are both equal to beta. So angle NPS equals to angle MPS equals to beta. We also have here a common side. PS is a common side, it belongs to both triangles, so PS equals to PS is a common side that belongs to both triangles. And those two angles are also equal to each other, they are both equal to 45 degrees, so angle NSP of the green triangle is equal to angle MSP of the white triangle, and both angles are equal to 45 degrees. So we actually proved that the green triangle PNS, congruent, this is the sign of congruent, to the white triangle PMS, according to angle side angle rule. I repeat again, we actually proved that the green triangle PNS can go into the white triangle PMS according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between those two angles in one triangle can go into two angles and the side that included in the other triangle, then you prove that those two triangles can go to each other according to angle side angle rule. And we proved that those two angles and side PS that is between them in the green triangle can go into those two angles, and the side between them, that is to say side PS, in the white triangle, then therefore we prove that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that NS equals to MS. NS equals to MS according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say NS and MS, will be equal to each other. So we'll join points N and M together by a straight line, and I will draw the right triangle NSM in a new page. So we have triangle M and S. This is a right triangle. And we know that MS equals to NS. MS equals to NS. And we know that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other, so those two angles are equal to each other. So if we define this angle as y, then this angle will be also equal to y. And y plus y must be equal to 90 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. This angle is 90 degrees, so those two angles must be equal also to 90 degrees in order to complete the sum of the angles in triangle NMS to 180 degrees. So we got that y plus y equals to 90 degrees, y plus y is 2y, 2y equals to 90 degrees. We will divide this equation by 2, and we will get that y equals to 90 degrees over 2, that is to say y equals to 45 degrees. So we found out that this angle MNS is equal to 45 degrees. And this angle also equals to 45 degrees. So first of all, we will join together points N and M together by a straight line. You know that NS equals to MS. We found out that angle MNS equals to 45 degrees, and angle NMS also equals to 45 degrees. So in the next step, we will prove that triangle PQN, this triangle, is congruent to triangle PNM. So I will draw those triangles together and in a new page, and we will prove that they can congruent to each other. So actually, we are talking on triangle PQN. And triangle PMN. So we actually prove that the green triangle, triangle PQN, can go into the white triangle, triangle PMN. Triangle PQN can go into the white triangle, triangle PMN. So why they can go into each other? First of all, we have already found out that PQ equals to PM. If PQ equals to PM, those two angles, they are equal to each other, they are both equal to beta. So angle QPN in the green triangle is equal to angle NPM in the white triangle. And both those two angles are equal to 2 beta. And repeat again, angle QPN in the green triangle equals to angle NPM in the white triangle, and they are both equal to 2 beta. And we also have a common side. PN is a common side, it belongs to both triangles. So we can write down that PN equals to PN. It is a common side that belongs to both triangles. So we actually proved that those two triangles can go into each other according to side angle side rule. I write it down. We proved that the green triangle, triangle PQN, can go to the white triangle, triangle PMN, according to side angle side rule. So I'll repeat again. We proved that the green triangle, triangle PQN can go into the white triangle, triangle PMN according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them in one triangle can go into two sides and the angle between them in another triangle, then you prove that those two triangles can go into each other according to side angle side rule. And here we proved that those two sides and the angle between them, that is to say 2 beta in the green triangle, can go to those two sides and the angle between them, that is to say 2 beta in the white triangle. Therefore we proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that Qn equals to Mn. Qn equals to Mn according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say Qn and Nm, will be equal to each other. So Qn equals to Mn. Here we can write down that Qn equals to Mn. Qn equals to Mn. So here we will join points Q and M together by a straight line. I will draw triangle QMN in a new page. And so this is triangle QMN. You know that Qn equals to Mn. Angle MQN equals to X. There we have, this is S. So we know that Qn equals to Mn, those two sides are equal to each other, and we know that in any triangle, in front of equal angles, there are equal sides. In front of equal sides, that is to say Qn equals to Mn, so in front of those two equal sides, there are equal angles. The two angles that are located in front of those two equal sides are those two angles. So according to the rule that I mentioned, those two angles must be equal to each other. But this angle equals to X, so this angle must be also equal to X, because those two angles are equal to each other. Okay, so here we can write down that this angle equals to x, and if we focus on triangle QNS, it has three interior angles, 1, 2, 3, and the external angle MNS will be equal, according to rule number 4, it is equal to the sum of the angles that are not adjacent to it. The two angles that are not adjacent to this external angle are those two angles, and the sum of those two angles are 2x, and the external angle MNS equals to 2x. So we found out that the external angle MNS equals to 2x according to rule number 4, because it equals to the sum of the angles that are not adjacent to it, that is to say it equals to 2x. But from the other side, we have already found out that angle MNS, this angle equals to 45 degrees. It equals to 45 degrees. Okay, so we actually found out this 45 degrees equals to angle MNS equals to 2x. From this equation, we will derive that 2x equals to 45 degrees. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2, that is to say x equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees. Exactly as we found in the first method. So angle x equals to 22.5 degrees. So now I'll summarize the lecture. Actually, we wanted to find out the value of angle x. We found out the value of angle x in two different methods. In the first method, we defined this angle as alpha, this angle as beta. We defined angle PSR as y, and we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So here, if we focus on the upper side of the straight line QR, then the sum of the angles at point S must be equal to 180 degrees, that is to say 45 degrees plus angle y equals to 180 degrees. 45 degrees plus angle y must be equal to 180 degrees. So here we will subtract 45 degrees from this equation, and we will get that angle y equals to 135 degrees. Angle y equals to, this angle equals to 135 degrees. And we also know that we have the law of sines that is applied in any triangle. So in this triangle, this side equals to A units in its length, this side equals to B units in its length, and this side equals to C units in its length. This is angle A, this is angle B, and this is angle C. So this triangle can be any triangle, and according to the law of sines, A over sine A over sine A equals to B over sine B equals to C over sine C. This is the law of sines. We can derive from the law of sines that A over sine A equals to B over sine B. So here we can divide this equation by B and multiply it by sine A, and we will get that A over B equals to sine A over sine B. So what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths in any triangle is equal to the ratio between the opposite angles. Okay? The ratio between the side lengths in any triangle, that is to say A over B, equals to the ratio between the opposite angles, that is to say sine A over sine B. Okay? Then we return to our triangle, to our drawing. In our drawing, we can create the equation that PS over QS equals to PS over SR. PS over QS equals to PS over SR. Why this is true? Question number 1 is true because of the fact that QS equals to SR. Okay? But according to the rule that the ratio between the length sides of any triangle equals to the ratio between the opposite angles, we will get that PS over QS in triangle PQS, PS over QS in triangle PQS, this triangle will be equal to sinus 3x over sinus alpha. It equals to sinus 3x over sinus alpha. And P in triangle PSR, PS over SR will be equal to sinus x over sinus beta. PS over SR equals to sinus x over sinus beta. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, consider that alpha plus 3x plus 45 degrees must be equal to 180 degrees. We will subtract 3x and 45 degrees from this equation, equation number 2, and we will get that alpha equals to 180 degrees minus 3x plus 45 degrees. Likewise, in triangle PSR, the sum of the angles is equal to 180 degrees. So that is to say, angle beta plus 145 degrees plus angle x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from this equation, equation number 3, and we will get that angle beta equals to 45 degrees minus x. So after we found out the value of alpha and beta, we can substitute alpha and beta in this equation, equation number 1, by the values that we found for alpha and beta in equation number 2 and equation number 3. So we did it here, and we got that sinus 3x equals to here sinus alpha is 180 degrees minus 3x plus 45 degrees, and it equals to sinus x minus beta, and beta according to equation number 3 equals to 45 degrees minus x. And we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we will get that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. So we can change equation number 1 by this expression. We did it here, and we got that sinus x over sinus 3x plus 45 degrees equals to sinus x over sinus 45 degrees minus x. Here we cross multiply the equation number 1, and we got this equation. Then we multiply the equation number 1 by 2, and we got these expressions. We simplified these expressions by the trigonometric identity that states that 2 sine A sine B equals to cosine A minus cosine B. 2 sine A sine B equals to cosine A minus B minus cosine A plus B. In our specific expression, A equals to 3x, B equals to 45 degrees minus x. So 2 sine A sine B equals to cosine A minus B. Cosine A minus B. A is 3x and B is 45 degrees minus x, so A minus B is 3x minus x is 4x. And 0 minus 45 degrees is minus 45 degrees. So we got here cosinus 4x minus 45 degrees. And we also must subtract cosine A plus B. So minus cosine A plus B. A plus B, A is 3x and B is 45 degrees minus x. So A plus B is 3x plus minus x is 3x minus x, that is 2x. And 0 minus 45 degrees is minus 45 degrees. So we got here minus cosinus 2x plus 45 degrees. So we finished with this expression. Then we got to this expression, 2 sine x sine 3x plus 45 degrees. Here A equals to x and B equals to 3x plus 45 degrees. And cosine A minus B will be equal to A is x and B is 3x plus 45 degrees. So it is x minus 3x is minus 2x. And 0 minus 45 degrees is minus 45 degrees. So we got here cosinus minus 2x plus 45 degrees, but according to the trigonometric identity that cosine minus x equals to cosine x, we can change the value of the negative sign here by the positive sign, because cosine x equals to cosine minus x equals to cosine x according to this trigonometric identity. So we change the sign of minus to the negative sign to the positive sign, and we got cosine 2x plus 45 degrees. And here we also have to subtract cosine A plus B. What is A plus B? A is x and B is 3x plus 45 degrees. So x plus 3x is 4x. And we have also 0 plus 45 degrees is 45 degrees. So in conclusion, we got here cosine 4x plus 45 degrees. So then what we have here, we have cosine 4x minus 45 degrees. We copied it here and we added to this equation number 1, cosine 4x plus 45 degrees. So it is cosine 4x plus 45 degrees. And what is left from equation number 1? We have here minus cosine 2x plus 45 degrees. So we added to this equation number 1, minus cosine 2x plus 45 degrees. And we got that cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. Okay, so we have here expression that is very similar to the trigonometric identity that states that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So 2 cosine C plus D over 2 is 4x plus 4x is 8x, and 8x over 2 is 4x. Okay, so we got 2 cosine 4x, because here 45 degrees minus 45 degrees is 0. So we got here cosine 4x, and we have also to multiply it by cosine C minus D over 2. C minus D is 4x minus 4x is 0, and minus 45 degrees minus 45 degrees is minus 90 degrees, minus 90 degrees over 2 is minus 45 degrees, but cosinus minus 45 degrees equals to cosinus 45 degrees according to the trigonometric identity that cosine minus x equals to cosine x. So we actually wrote there cosine 45 degrees instead of cosine minus 45 degrees. And we have also this expression 2 cosine 2x plus 45 degrees, and we simplify this expression by the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A times sine B. Here A equals to 2x, B equals to 45 degrees. So we have 2 cosine C plus D over here. It is cosine A, cosine B. A is 2x, B is 45 degrees, so it is 2 cosine 2x, cosine 45 degrees, minus sine A times sine B. So it is minus 2 sine A is 2x, and sine B is 45 degrees, so sine B is sine 45 degrees. Then we divided this equation by 2 cosine 45 degrees, and we got that here what is left after we divided the equation by 2 cosine 45 degrees. Here we have cosine 4x that equals to cosine 2x minus sine 2x. Okay, we got cosine 4x equals to cosine 2x minus sine 2x. Then we actually added to this equation sine 2x and subtracted cosine 4x. So in conclusion we got that sine 2x equals to cosine 2x minus cosine 4x, but sine 2x equals to 2 sine x cosine x, and cosine 2x minus cosine 4x is very similar to the trigonometric identity that cosine C minus cosine D equals to 2 sine D minus C over 2, D plus C over 2 times sine D minus C over 2. Here C is 2x and D is 4x. So 2 sine D plus C over 2 is 2 sine 4x plus 2x over 2. 4x plus 2x is 6x, and 6x over 2 is 3x. So we got here cosine 2 sine 3x, and we have to multiply it by sine D minus C over 2. D minus C is 4x minus 2x, that is to say 2x. 2x over 2 is x. So in conclusion we got that 2 sine x cosine x equals to 2 sine 3x sine x. We divided this equation number 1 by 2 sine x, and we got that cosine x equals to sine 3x. But according to the trigonometric identity, that cosine alpha equals to sine 90 degrees minus alpha, we'll get that cosine x equals to sine 90 degrees minus x. So sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to 3x. We added to this equation number 1 x, and we got that 90 degrees equals to 4x. We divided this equation number 1 by 4, and we got that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out that the value of angle x equals to 22.5 degrees. So we finished with the first method. Then I presented to you how to find out the value of angle x using the second method. In the second method, we actually again we define this angle as alpha, this angle as beta, and we have already found out that this angle equals to 135 degrees. And we also know that the sum of the angles in any triangle is equal to 180 degrees, so the sum of the angles in triangle PQS equals to 180 degrees. That is to say, alpha plus 3x plus 45 degrees in triangle PQS equals to 180 degrees. We subtracted 45 degrees from this equation number 1, and we got that alpha plus 3x equals to 135 degrees. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus x plus 135 degrees equals to 180 degrees. We subtracted 135 degrees from this equation number 2, and we got that beta plus x equals to 45 degrees. We multiplied the equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So, in both sides, in both equations, equation 1 and equation 2, we have one side that equals to 145 degrees, so we can say that equation number 1 equals to equation number 2, that is to say alpha plus 3x equals to 3 beta plus 3x. We've subtracted 3x from this equation, equation number 3, and we found out that alpha equals to 3 beta. Okay, alpha equals to 3 beta. Then we did the construction from point Q. We drew a straight line to PR in such a way that this angle equals to x. So this angle equals to x, this angle also equals to x. So triangle QMR is an isosceles triangle, and the base of the isosceles triangle, triangle QMR, is QR. MS is the median to the base. The median to the base bisects the base, but is also perpendicular to the base. That is to say, those two angles are right angles. Then I presented to you rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC has 3 interior angles, that is to say alpha, beta, and gamma, and angle SAB is an exterior angle of triangle ABC. And according to rule number 4, the value of this exterior angle will be equal to the sum of the angles that are not adjacent to it. The two angles that are not adjacent to it are those two angles, and the sum of those two angles is alpha plus beta, so the value of the exterior angle SAB is alpha plus beta according to rule number 4. We can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle QMR, and the angle PMQ is an exterior angle of the isosceles triangle QMR, and the value of the exterior angle PMQ according to rule number 4 is equal to the sum of the angles that are not adjacent to it. Those two angles are not adjacent to the exterior angle PMQ, therefore, and the sum of those two angles is 2x. That is to say, the value of the exterior angle PMQ is 2x. But those two angles are both equal to 2x. Therefore, triangle PQM is an isosceles triangle. In this triangle, we can say that in front of equal angles there are equal sides. That is to say, in front of those two angles that are equal to each other, they are both equal to 2x, there are equal sides. That is to say, PQ equals to PM. PQ equals to PM. Then we drew perpendicular to QM, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. We extended the perpendicular until it touches QS at point N. We focus on those two triangles. We know that PQM equals to PMQ equals to 2x. Those two angles are both equal to 2x. They are equal to each other. Those two angles are also equal to each other. They are both equal to 90 degrees. And those two angles will be equal to each other according to third angle theorem. According to third angle theorem, if you have two angles in one triangle that can go into two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Okay? So those two angles are equal to each other. So if we define this angle as theta, then this angle in the red color must be also equal to theta, because they are equal to each other. And from the drawing you can see that theta plus theta equals to alpha plus beta. Okay, theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and 2 theta equals to alpha plus beta. But according to equation number 3, alpha equals to 3 beta, so we can substitute alpha by 3 beta. We did it and we got that 2 theta equals to 3 beta plus beta, that is to say 2 theta equals to 4 beta. We divided this equation by 2 and we got that theta equals to 2 beta. So you can write here that theta equals to 2 beta, and here also theta equals to 2 beta. But as you can see from the drawing, if we subtract the red angle, angle NPR minus this angle that is angle beta, we will get angle NPS. The red angle is 2 beta, this angle is beta. 2 beta minus beta is beta, so angle NPS must be equal to beta. Likewise, angle MSN is a right angle. This angle is 45 degrees. Angle PSN is 45 degrees. So 90 degrees minus this angle that is 45 degrees will be equal to this angle. 90 degrees minus 45 degrees is 45 degrees. Therefore, this angle, angle MSP, equals to 45 degrees. Then we proved the triangle PNS is congruent to triangle PMS. I drew those two triangles in a new page together, and we proved that they can congruent to each other. We proved that the green triangle can congruent to the white triangle. Why they can congruent to each other? First of all, we have those two angles that are equal to each other. Angle NPS equals to angle MPS equals to beta. PS is a common side that belongs to both triangles, so PS equals to PS is a common side that belongs to both triangles. And those two angles, they are both equal to 45 degrees, so they are equal to each other. Therefore, we prove that those two triangles can go into each other according to angle side angle rule. Okay, so what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side between them in one triangle can go into two angles and the side between them in the other triangle, then you prove that those two triangles can go into each other according to angle side angle rule. And we proved that those two angles and the side between them, that is to say PS in the green triangle, can go into those two angles and the side between them, that is to say side PS in the white triangle. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. From the fact that those two triangles can go into each other, we will prove that NS equals to MS. NS equals to MS. So we join together points M and N together, and then I draw triangle M and S in a new page. We also join points M and N here. And so we know that NS equals to MS. And then I draw triangle NMS in a new page. In this page, as you can see here, we got to the conclusion that MS equals to SN. Those two sides are equal to each other. And this is the right side. It equals to 90 degrees. In front of equal sides in the triangle, there are equal angles. So those two angles must be equal to each other because they are located in front of equal sides. So if one angle is y, the other angle must be also equal to y. So if this angle is y, this angle also must be equal to y, and y plus y must be equal to 90 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So we got that 2y equals to 90 degrees. We divided this equation by 2 and we got that y equals to 45 degrees. So this angle equals to 90 degrees and this angle equals to 45 degrees, and this angle also equals to 45 degrees. So we found out that angle MNS equals to 45 degrees. Angle MNS equals to 45 degrees. And this angle also equals to 45 degrees. Then we proved that triangle PQN can go into triangle PMN. I drew those two triangles together and we proved that the two triangles can go into each other. We proved that the green triangle, triangle PQN, can go into the white triangle, triangle PMN. Why they can go into each other? First of all, PQ equals to PM. You can see here, PQ equals to PM. PQ equals to PM. Those two angles are equal to each other, they are both equal to 2 beta. So angle QPN equals to angle MPN equals to 2 beta. And they have also a common side. PN is a common side that belongs to both triangles. So PN equals to PN is a common side that belongs to both triangles. So we proved that the green triangle, triangle PQN equals is congruent to the right triangle, triangle PMN, according to side angle side rule. What is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you prove that those two triangles congruent to each other according to side angle side rule. We prove that those two sides and the angle between them, that is to say 2 beta, congruent to those two sides and the angle between them, that is to say 2 beta, to the green triangle. So we prove that those two triangles congruent to each other according to side angle side rule. And from the fact that those two triangles congruent to each other, we conclude that Qn equals to Mn. According to the rule, the corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides Qn and Nm must be equal to each other. So, I joined points M and Q together with a straight line, and I draw triangle QMN in a new page. Here we know that angle MQN equals to x. Here angle MQN equals to x, and we just right now proved that Qn equals to Mn. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are located in front of the equal sides must be equal to each other. But this angle equals to x. So this angle must be also equal to x, because those two angles, they are equal to each other. So we have in triangle QMN, we have two angles that are equal to 2x, and according to rule number 4, the value of the exterior angle MNS, angle MNS is an exterior angle of triangle QMN, and the value of the exterior angle MNS is equal to the sum of the angles that are not adjacent to it, and the sum of the two angles that are not adjacent to it, the two angles that are not adjacent to it are those two angles, and the sum of the two angles that are not adjacent to it is x plus x. So we found out that the value of the exterior angle MNS of triangle QMN equals to 2x. From one side we know that angle MNS equals to 2x according to rule number 4, but from the other side we have already found out that angle MNS equals to 45 degrees. So we got this equation. From this equation we will derive that 2x equals to 45 degrees. We will divide this equation by 2, and we will get that x equals to 45 degrees over 2. 45 degrees over 2 is 22.5 degrees. So we found out that the value of angle x is 22.5 degrees. So in both sides we found out that the value of angle x is 22.5 degrees. Okay, thank you very much.